In this question, we are going to solve another application problem for the linear programming concept. Nutrition. Mike May has been told that each day he needs at least 16 units of vitamin A, at least 5 units of vitamin B1, and at least 20 units of vitamin C. Each branch X pill contains 8 units of vitamin A, 1 of the vitamin B1, and 2 of the vitamin C, while each brand Z pill contains 2 units of vitamin A, 1 of vitamin B1, and 7 of vitamin C, and brand C pill costs 15 cents, and brand X pills cost 15 cents, and the brand Z pill costs 30 cents. How many pills of each brand should he buy to minimize his daily cost? And what is the mean cost of the one that he's buying? Alright, so this problem looks very complicated, and it seems like we are given a lot of info in wordings here. It's confusing us when we read the problem. But if we can translate this into some type of linear equation, linear inequality, and then apply the concept of linear programming, then we can actually solve for that. But the first thing is we have to define some variable. So they ask you, look at the question. The question asking us for how many pills. So that is what they are asking you. How many pills for each branch? We have what? We have branch called X and another branch called branch Z, right? We have 2 branch X and branch Z, and they ask you how many pills of each branch. Well, they ask you for that, so you should let the variables X and Y to represent the number of the pills from branch X and branch Z. So let X represent the number of the brand X pills, right? And then let Y to be the number of the brand Z pill, because they ask you for the number of the pills, so that's why you let X and Y to represent the variable that we are solving, we are looking for. Now there are the constraint requirements, and there is an objective function. So let's consider about the constraints. Constraint from the problems. So the constraints imposed by the amount of vitamin A is what? So we are looking for vitamin A. So let me call vitamin A. This is vitamin A. You know that vitamin A, he has been told that each day he needs at least 16 units. At least means bigger than or equal, right? Bigger than or equal. So how do we do that? Well, X is the number of the branch X pills that he's using, and Y is the number of the branch Z he's using. So I am just looking for, you know that from branch X contains 8 units of vitamin A. So that is 8 units, right? 8 multiplied with X, which is the number of the pills. And then for vitamin A, for branch Z, it contains 2 units of vitamin A. 2 units of vitamin A. So 2 multiplied to the number of Y, which is the number of the pills. And when you add them together, when you add the 2 pills together, make sure that at least you get 16 units. So that is about the vitamin A. Now, what about the constraints imposed by the amount of vitamin B1? So for vitamin B1, the doctor told him that he needs at least 5 units. So at least 5 units. And again, from the branch X, 1 of the vitamin B1 it has only one unit of vitamin B1. So 1 times x is x. And then for brand Z, we have what? We have 1 of vitamin B1. So just y. 1 times y is y. And bigger than or equal to 5. And then lastly, we have what? We have the constraint imposed by the amount of vitamin C. Vitamin C is a last vitamin. So for vitamin C, he needs at least 20 units of vitamin C daily, right? 20%, I mean 20 units. So at least 20 units, so bigger than or equal to 20. And I know that from brand X, it had 2 units of vitamin C, so 2 times X. And then for brand Z, the brand Z pills contain 7 units of vitamin C. So plus 7 times Y, because Y is the number of the brand Z pills. And that is the constraint inequality, linear inequality that you get from the problem. And because X and Y represent the number of the pills, so you cannot have it as a negative value, right? Doesn't make sense in this context. So make sure that we have another 2 more linear inequality. X need to be bigger than or equal to 0, and Y need to be bigger than or equal to 0, because we cannot get a negative value for the number of the pills. So that is your constraint linear inequality. And now let's see what is the objective functions. So now we are looking for the mean cost to minimize his daily cost. Well, we can write his daily cost Z. We can write that. You know that brand X pills cost 15 cents. 15 cents mean 15 multiplied with X, because X is the number of the pills from brand X. And then 30 cents for the brand Z. So plus 30 Y, and Y represent for the number of the pills from brand Z. And that is the cost function. This is the cost function. The cost function from his daily cost. So you want to minimize this cost function. Okay. So the first thing is we have to be able to plot all of the constraint equations on the XY plane and see what we get. So let's do that. We can do it here. So this is the X, this is the Y, right? All right, so let's do the first one first. So all of them have the equal sign, so we should draw the solid line, not the dashed line. So the first equation, how can I graph it? I can use the X and Y intercept. When my X is 0, I have 2Y. You can represent that equal 16. So in order to graph this linear inequality, first I'm just writing that and then replacing the inequality by equal sign. So I find the x-intercept. When my x is 0, I have 2y equals 16, therefore y is 8. So 0, 1, 2, 3, 4, 5, 6, 7, 8. So 0 and 8 is my x-intercept. For y-intercept, I put x to be 0. For x-intercept, I put y to be 0. So when my y is 0, I have ax equals 16, or my x should be 2. So right here. So that is my my equation, and I'm connecting that. And again, I don't go all the way down here. I don't go all the way up here because I cannot have negative for x and y. So I stop at, so everything should be in the first quadrant. So that is my first linear inequality. Now, my second one is x plus y bigger than or equal to 5. I can also do that. X plus y, put this into the equal sign. When my x is 0, my y is 5, which is right here. When my y is 0, my x is 5. So that is by 3, 4, 5. So we are looking for x and y intercept. And again, I'm connecting the line together. Again, I'm staying inside the first quadrant only due to the this conditions here. So that is my second linear inequality. Then my last one right here, how can I wrap this one? Well, first thing is I'm just replacing the linear the inequality side by equal, and then I'm finding the x and y intercept. When I'm looking for my y-intercept, I let x to be 0, right? So that's gone. I have 7y equal 20, and then y equal 20 over 7. So I have 20, 7y equal 20, and then y equal 20 divided by 7. So that is around, that is like almost 3. Right, so that is something like around here, very close to 3. 3 is right here, so 2.9 something, that's around that. That is 20 over 7. And then after I get the y-intercept, then I'm looking for the x-intercept. When I want to find the x-intercept, I put, when I want to find the x-intercept, I put my y to be 0, right? So y 0. So divide both sides by 2, my x is 10. So 10 is all the way here. And now this point, I'm ready to connect them together, right? And you see that we get 3 different lines, and you have to be able to shade the region and see which one is the solution. So consider back to this vitamin A, this one right here. Let's use the test point. This one is this line right here. So I'm using the 0, 0 at the test point. When I have 0, 0 plus 0 bigger than 16, that is not true. That is not true. Therefore, I shade the other region. Okay? Use the test point. And then for the next one, x plus y bigger than or equal to 5, which is the real one. And then again, I'm using the test point to be 0, 0. So 0 plus 0. 0 cannot be bigger than 5, so that is also not true. So the origin is not inside the solutions. So I'm shading this portion, right? And then finally, the last one, again, I'm putting 0 and 0. So if I put 0 here, 0 here, x, y to be 0 as the origin, then the left hand side have 0, 0 bigger than or equal to 20, which is not true. So again, I'm shading the opposite direction. Okay. So now you see that we end up with the area up here. We end up the area up here. Right. So if I erase them, I can make it look nicer. I can shade the area. So this is the solution of everything, right, above here. The common solution to this problem. And then it just keep going forever up all the way here. Right, all the way here. So that is the solution of the 3 constraints. I mean 5 of them. Alright, so this is your solutions. And now we apply the corner theorem. We are looking for the corner point. So this is one of the corner. Right, this is one of the corner. This is the second corner. This is the third corner. And this is the last corner. I know that this location 10 and 0. I know that this location is 0 and 8. But I don't know this location, these 2 points. So we can solve for that. We can solve for that. I know that this point right here, is the intersection between the blue, right? The ax plus 2y 16, and that is the intersection between that and the real one. The real one is right here, x plus y equal 5. So I can quickly solve for that. You can solve for this system equation for x and y. So maybe I can multiply -2, right? So that will give me ax plus 2y equals 16, -2x, -2y equal -10, and I can add them together, which cancel out a y term. Ax minus 2x plus 6x equal 10 subtracted from 16, that is 6. So x is 1. When my x is 1, I plug in one of the two equations. So let's just plug in this equation. A times 1 is 8, plus 2y equals 16. And then subtracting a on both sides, 2y equal 8, and y equal 4, right? 4. So that point is 1 and 4, right here. 1 and 4. So that's how you solve for that. And then finally, we need to look for the other point. The last one. We need to look for all the corners points. This one is the intersection between the green line. The green line is x plus y equal 5, and the purple one. The purple one, 2x plus 7y equal 20. And then again, in this case, maybe I'm going to multiply both sides by -2. So I get what? -2x, -2y, -10, and then I keep the second equation to be the same. And why do I do that? Because now I can add them. -2 and +2, they are gone. 7 minus 2, 5y. 20 subtract 10 is 10. So divide both sides by 5. My y is going to be 2. So to y 2, I can go back to maybe this equation. I have 2x plus 7 times y. Y is 2, so 7 times 2 is 14 equal 20. Then 2x equal 20 subtract 14, that is gonna be 6, and x divide both sides by 2 give me 3. So x is 3 and y is 2 is this location. So now we have everything. We have all the point, right? We have all the point. But we need to be able to use the corner points theorem. Alright, so after you have everything, then I am going to use the corner points theorem together with the objective function. Okay, so let's do down here. I have what? I have the corner point, and I have my cost function that I'm looking to minimize the cost. So that is 15x plus 30y. So we have 4 corners. 0, 8, 1, 4, 3, 2, and then 10, 0. So x and y. Okay. So when I have 0 and 8, I just plug in. Oh, you know what? That's a very small mistake right here. 15 cents. If you are writing this in terms of dollar, this should be 0.15, and this is 30 cents, so that should be like 0.30 in terms of dollars. So make sure you put the 0.30 because we are writing everything in terms of dollars. So this should be 0.15 and 0.30. All right. So 0 for x. So we have 0.15 times 0 plus like 0.30 times y. Y is 8. If I do the calculation correctly, I should get $2.40, $2.40. And then I do the same thing here, 0.15 times 1 plus 0.30 times y. Y is 4. And if I do it correctly, 1.35. And then I do the same thing here, 0.15 times 3. And then plus 0.30 times y. Y 2. And that is going to be 1.05. And lastly, 0.15 times x is 10 plus 0.30 times y is 0, and that is going to be 1.50. Now go back to the problem. The problem wants you to find the mean value. You want to minimize this value of the cost function. So between 1, 2, 3, 4, which one has the smallest value? Of course, 1.05 is the smallest value. And therefore, this is the smallest value. And that means his daily mean cost is $1.05. So you can write a conclusion. He can satisfy the requirements with, and then with this amount of dollar, he has to use what? He has to use 3 for X, 2 for Y, and X is a number of the branch X pill, Y is a number of branch Z pill. So he can satisfy the requirement with 3 branch X pill and 2 branch Z pill for a mean cost of $1.05 every day. And that is the answer of this problem using the linear programming concept together with the corner point theorem.